Okay, so we are looking at note page 13, continuing in with the ideas of energy. So we looked at the law of conservation of energy. Energy cannot be created or destroyed, but during a process of change, physical, chemical, or nuclear, energy can be transferred between two materials that are touching each other. But the other thing that can happen to energy is that energy can actually change forms. So a great example is, how do we get light out of a light bulb? So one place would be using a flashlight. In order for the flashlight to work, it has to have a battery in it. The battery represents chemical energy. So a chemical reaction happens in the battery, and as that reaction happens, the ability to do work starts to travel down the metal contacts within the flashlight, and that's what we call electrical energy. And then ultimately, that electrical energy hits the light bulb and it flows through a filament, and the filament gives off that radiant or light energy. So we start off with one form of energy and it goes through a series of changes, and then whatever we use that piece of equipment for, it ultimate change or the final change is into the form of energy that is most useful for us. Now, looking at some practice problems. So you will see through these notes that there are practice problems that are called I do, we do, you do. And in the videos, I will go through the I do and we do. And if you are absent, I hope that you try the you do on your own, and then you bring it to me so that I can check for your understanding to make sure that you have a good handle on the information. So let's take a look. Practice problems for the natural heat flow. So the I do. An ice pack is placed on an athlete's injured ankle, and then my job in this question is to identify the direction of the heat energy flow. So first thing I do is I'm going to write myself a reminder is that heat energy, when it flows between two samples, it always flows from the warmer sample to the cooler or colder sample. Now, the two materials that are going to come into contact in this question, one is an ice pack, which you are probably familiar with, and an ankle, which is part of the human body. Now, an ice pack, when you touch it, is pretty cold. We haven't talked about temperature scales, so I'm going to stick to our everyday scale. Thinking about weather is the ice pack, since it starts off as ice, its temperature is less than 32 degrees Fahrenheit, so I'm just going to say 30 degrees Fahrenheit. Whereas the ankle is part of the human body, and we know that the healthy average temperature of a human body is a little bit more than 98 degrees Fahrenheit. So when I think about one material compared to the other material and I compare their temperatures, the person's ankle is much warmer than the ice pack that's going to be placed on it. And so ice pack. So because of that, the heat transfer occurs from the person's ankle to the ice pack. So this is the direction of the heat flow. And making like a little diagram like I did instead of writing out a sentence is perfectly fine to answer a question like this one. Moving on to the we do. So once again, if we look at the last sentence in the task, it says, draw arrows to indicate the direction of heat flow. Notice in our picture, we have 3 blocks, A, B, and C, and each one is at a different temperature. So first thing, quick reminder, is that the natural direction of heat flow, it moves from whichever sample is warmer, and it transfers heat to the sample that is cooler, has the lower temperature. Now, this type of natural heat flow, warmer to the cooler sample, the two samples have to actually be in contact. So they have to be touching. So I'm going to write in contact or touching. So we have three different blocks, but if you take a look at how the drawing is made, not all three blocks actually are in contact or touching each other. So when I look at block A, it is actually only touching block B, but not block C. So there's a heat transfer between A and B because they are at two different temperatures. So the heat flow is always from the warmer to the cooler. So block B is at 5 degrees Celsius. And don't miss the details. So if you look too quickly, block A looks like it's at 20 degrees Celsius. Don't miss that negative sign. So it's actually negative 20 degrees Celsius, much colder than 0 degrees. So it's less than 0 degrees. So in this particular, between these two blocks, heat leaves B and is given to A, since B is at a warmer temperature than A. Now, B is also in contact with block C. And when you look at their temperatures, block C's temperature, 100 degrees Celsius, is much warmer than block B's. So the direction of the arrow here would be from block C to block B. But we would not draw any arrow between A and C. Yes, they are two different temperatures, but they actually don't touch, so there is no transfer between blocks A and C. So looking at those two examples, I would like you to try the you do and then show it to me so we can go over it together. Looking at the practice questions. So these are questions that have come from previous exams, typical questions dealing with some ideas in energy. So take a look at question 1. So here it states, the energy absorbed by a substance can be measured in. So the quantity being measured is energy. And when it says measured in, it's asking us to identify the unit. How do we measure energy? Some of these terms are probably pretty familiar. So you see the term degrees. Degrees is not used for energy, but it is a lot of times represented when we're talking about energy. Degrees is used when we're measuring temperature. And temperature is not a form of energy. So when it asks energy absorbed, a form of energy can be quantified or measured in what unit. Then we have joules. We have grams. Grams you should recognize for a quantity that you have probably measured many times, mass. Now a newer unit, liters per mole, which is something that we will look at later on. And so when we are comparing moles and liters, we are probably working with solutions and dealing with concentration. So the best answer here for this question is joules. Now question 2, pretty common question. Every response here has a list of answers in it. And it says which list includes 3 forms of energy. So in reality, we recognize that there are a total of 8 forms around us. So think about on page 12 what we listed, and we have to choose a list that has at least 3 of them. So a great test taking technique for questions like these is you look at a response, and if you find one word that doesn't fit in that response, cross it off, and that is not the best answer. So when I'm looking through here, thermal, good. Nuclear, definitely a form. Here's a word, probably have never seen this word yet. Ionization, definitely not part of the 8 forms of energy. Moving on to letter B, thermal. good. Chemical, good. Look at that, electromagnetic. We now know that that has something to do with light energy. And then continue on just to make sure that you didn't oversee or you're making a quick decision. So check your other responses. So when I take a look at response C, I see that tricky word temperature, because a lot of times when we're in the unit of energy, we have to incorporate temperature into our thought process, but temperature is not a form of energy. And I see it listed in response C and D. So I know automatically, no matter what else is listed there, C and D are not the answers. So the only answer, or the best answer for this question, would be response B. Okay, moving to question 3. Here we go. Which form of energy is transferred, okay, when an ice cube at 0 degrees Celsius is placed in a beaker of water at 30 degrees Celsius? So I see that one sample is at 0 degrees Celsius and another one is 30 degrees Celsius. So what form of energy is transferred from a warmer sample to a cooler sample? Because it says the ice cube is placed in that water, so that means they're going to be in contact. So what we have learned is the term heat. So now you need to remember or make an association. What other term also can be represents the same form of energy as heat? And so when we look through our list, thermal energy. Thermal is another term for heat. So response D is the best answer. So this question is two-step. Do you know what energy transfers from warmer to cooler? And you also know its less common name. Looking at the final question in this set, question 4. Cube X at 20 degrees Celsius is placed in contact with cube Z. So I have cube X, and it is going to be touching and in contact with cube Z. Sometimes I need to draw pictures to help me understand better what the question is asking me. Cube X is 20 degrees Celsius and cube Z is 60 degrees Celsius. Which statement describes the initial flow of heat between the cubes? Well, heat flow, as we have talked about, even back up here, that heat flow, right? So heat flow, it is always warmer to the cooler. It always goes from the sample with the higher temperature and transfers to the sample with the lower temperature. So when I look at this, I have a 20 degree sample versus a 60 degree. They're put into contact. So it goes from the warmer to the cooler. So now I need to read carefully. Heat flows from cube Z to cube X. Heat flows from cube X to cube Z. Now take a look. See, response C, heat flows in both directions. We know that's not true because it goes from warmer to cooler. And then it says heat does not flow between these cubes. Well, we know that that statement's not true because number one, they are at 2 different temperatures and they're placed in contact. So there definitely is a heat flow. So the heat flows from the warmer to the cooler. And in this case, Z, which is at 60 degrees, will transfer heat to X at 20 degrees. So A is the best response.